And I was just like, holy smokes, what are we doing putting all of this incremental effort into energy efficiency when the building materials are just this huge percentage of global emissions?
What if the buildings we construct today could solve the problems of tomorrow? Welcome to the Passive House podcast, where we explore the ideas, people, and practices transforming the way we build. Brought to you by Passive House Accelerator and the Reimagined Buildings Collective. Join a growing movement of builders, designers, and changemakers levelling up their practice and building the networks they need to thrive. Find free resources at passivehouseaccelerator.com and take it further inside the Reimagined Buildings Collective, our members-only community built for people serious about healthy, climate-ready buildings. Welcome back to the Passive House podcast. I'm Matthew Cutler, coming to you from Auckland, New Zealand, and I'm joined this week by Jay Fox. How you doing, Jay?
I am doing very, very well. How are things with you?
Good. I've been traveling around. I had a very interesting conference last week, which was about community housing, which is always needed and very interesting to see what people are doing in that space here in New Zealand. There's a growing, seems to always be an increasing demand for community housing and increasing challenges to providing it. So that was interesting. And then being down in Christchurch talking about energy modelling, which is another favourite topic of mine. So yeah, been busy.
Very cool. I've been busy with my tomatoes because it's getting to the height of the summer and I've got different tomato plants.
Nice. Yeah, well, it is coming up to a bit of a break time for Accelerator, but we do, continuing on with the podcast, we've got lots of great interviews coming up, including this week, where we're going to be deep diving into carbon and low carbon, particularly concrete and cement and other materials, which is quite fascinating, looking at some of the history of carbon, of cement and concrete too. So we'll get into that. But before we do, we've got a few people to thank, including our stakeholder partner, NYSERDA. Also, our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwall, and Zola Windows. Thanks also to our champion sponsors, Buizo, Cascadia Windows and Doors, DuraPanel, Icon Windows and Doors, Intis Windows, LG, Proseco, Source 50, and Zender. And I'd like to do a special thanks this week to the sponsor of the week for the Passive House Accelerator, which is Oakley Woodworks. And Jay, you were just saying that they do some pretty spectacular work, some pretty incredible, what would you say, realistic to the existing architecture?
Yeah, historic retrofit, super high performance, and just like they are, when it comes to really detailed quality and good woodworking, I mean, they're kind of hard to beat. They're also based in Mobile, Alabama, which is, I thought, very cool.
I love that combination of high performance but historically accurate. It's very cool. All right. Well, let's jump in and we'll have a chat afterwards, because Jay, you caught up with Mikhail recently and had a great conversation about low carbon materials. So let's listen in and we'll catch up afterwards.
I'm joined today by Mikhail Haramati, the State Industrial Decarbonization Lead at NRDC. Mikhail, thank you so much for joining me.
Oh yeah, it's a pleasure.
Cool.
I've been listening to the Passive House podcast for a number of years, so it's an honor to be on it.
Can you tell us a little bit about your academic and professional background and, how that ultimately led you to the materials side of decarbonization?
Yeah, I'm happy to. So I'm one of those people who got undergraduate and graduate degrees and am still working in the same area. So I have a resume that looks very intentional, but it was built just sort of like, one step at a time. So I did my A in public policy from Mills College in Oakland, California, and I focused on science and technology policy. And this was a few years after the energy crisis. And so I did a class project on the California Public Utilities Commission. And it was for my organizational behavior class, looking at kind of the structure and hierarchy of the organization and how that might have contributed to the response to the energy crisis. And I was encouraged to do an internship there after interviewing the director of the energy division, and then eventually also encouraged to take the civil service exam, and ended up working at the energy division right after graduating from undergrad, planning and evaluating the state's energy efficiency programs, which were um, sort of the largest and most robust in the country at the time. So I did that for 5 years and realized that I wanted to make more of an impact on the policy side than just kind of like fighting about what had happened in the past in terms of calculating impacts of savings impacts from the utility run energy efficiency programs in California.
Mhm.
So when I went to grad school at UC Berkeley, I focused on kind of other ways where that might be possible. I worked at Lawrence Berkeley National Lab, working on international policy initiatives through the Clean Energy Ministerial that was currently being led by DOE on the technical side for the US government, and then also did some work for the California Energy Commission and the governor's office, and kind of got a broader perspective. And after grad school, ended up working at the California Energy Commission,
Mhm.
where I led the building efficiency R&D team, which felt like it was more aligned with my goals of really trying to lead improvements in the space.
Mhm.
And it was through that work that I learned about NYSERDA in New York State and had the opportunity to switch coasts and help write the carbon neutral buildings roadmap for New York, which is the plan to decarbonize New York's building stock by 2050 in line with Climate Act goals. So that was a very exciting opportunity to kind of like take a lot of what I'd learned in California over the last decade and apply it to a state where it was like a little bit more in the planning stages and still kind of like coming up with the strategies for how to achieve those reductions. And then when I was at NYSERDA working on that, and then subsequently the building chapter for the scoping plan for the Climate Act, I did a number of interviews and kind of research to support the modeling and the strategies that we were putting forth in the plan, and kind of uncovered just the huge savings potential on the material side.
Mhm.
And it was a thing that was pretty new to me. And I, had over a decade of experience at that time and had come from a policy environment in California where it felt like we were just, and New York for that matter, kind of like squeezing more and more energy savings out of the building sector on the operational side. And, these things were like the savings were getting more expensive and harder to achieve. And then I was sort of looking at the numbers and rudimentary analyses for the materials, and I was just like, holy smokes, like, what are we doing putting all of this incremental effort into energy efficiency when the building materials are just this huge percentage of global emissions? So concrete, for instance, is concrete and cement contributes 8% to global emissions.
Mhm.
And just sort of astounding numbers. And one of the stats that really stuck with me is the Architecture 2030 estimate that over the next 25 years through 2050, more than half of the emissions from the construction of new buildings will come from the materials. And that kind of that knowledge, I was like sort of sat with it, and more, it felt like it was hard for me in good conscience to continue working on incremental energy efficiency, knowing that there is this whole other area that's hugely important that
Mhm.
no one was working on and no one was championing in a really significant way at the state. So my boss at the time at NYSERDA encouraged me to put a white paper together and a set of recommendations for New York State.
Wow.
And so that's how I became kind of like the state lead and real proselytizer for it at NYSERDA and within the New York State environment.
Wow. Yeah, because I've been in the space for about 7 years and primarily dealing with the passive house side, so operational side. And embodied carbon wasn't, it was barely a conversation until relatively recently. I mean, even among diehard environmentalists, it was like kind of this niche thing. So it's really cool how quickly this is kind of like scaled up. And that said, I mean, reaching out to New York obviously has a climate act, and New York's been kind of a leader. But as somebody working a larger stage now, what are there other, I don't know, are there other states that are kind of implementing policies that you know about that are not New York, and like how is the policy overall kind of evolving on the subject of embodied carbon?
Yeah, there are a number of states. I think there's 8 states now that have passed Buy Clean initiatives
Hmm.
for that include embodied carbon for use of materials that have a high amount of emissions associated with them, commonly used building materials. And those include like California, Washington, Colorado. Massachusetts has been looking into this recently. Oregon has a number of interesting initiatives in the space. It's an area where there's both legislation and kind of like meaningful state action and local action. And it's, I think, been really exciting to me in particular because a lot of the embodied carbon work I've been seeing has very much been driven by like professionals in the local community. And
Hmm.
I think that like kind of similar to Passive House, it like kind of has started with a few just sort of curious folks that are like, hey, what can we do in this area? What's
Yeah.
possible here? And it also is like fairly regionally specific in terms of supply chains
Hmm.
and what materials and products are available locally. So on the one hand, there's kind of like statewide action, which is about harnessing the very considerable purchasing power of the government. So
Yes.
for instance, over half of all the concrete in the US is purchased by governments. So to give you a sense of kind of the magnitude there. But it's also sort of like the individual design professionals that are the ones that need to kind of like make that happen in
Mhm.
terms of finding the suppliers and integrating the materials into the designs.
Nice. And this is maybe a little bit out of order here, but I'm just thinking about we had a, I forget his name, Brad Guy recently who spoke about building for deconstruction. So specifically like for designers, you're about to build this house. This is how like in 70 years time you make it in such a way so that's a little easier to pull apart and reuse some of those materials. Are you seeing any like policy uptick in that concept, the building for deconstruction so that these materials last longer and that can help drive down embodied carbon a little bit? Or is that still, kind of a ways out?
I mean, we're seeing definitely more of it than, let's say, 5 years ago.
Mhm.
And there's a lot of interest, but I think it's sort of a question of scale. And so one of the reasons why I've spent most of my career working at the state level is because it's sort of large enough to matter, but not so large an area of focus where you lose track of individual projects and what's actually happening.
Hmm.
And I think in order to have a meaningful reduction on the emissions from the manufacturing of these different materials, you
Mhm.
really have to adopt policies that make changes at scale. And reuse is a tricky one because it's all about local supply
Yeah.
and kind of like what you have available. And so I think that the way to scale reuse is really to adopt it like across the US at the like city or sort of like regional market level. And
Mhm.
there's been a lot more interest in that happening in the last couple of years. And I think it's really exciting. I mean, there's just like a lot of awareness about it. And I think particularly as there's material and supply shortages, being able to kind of look around to say, does this material that I'm looking for, this product, actually exist in my ecosystem already?
Yep.
And is it in a waste stream or potentially a building that's about to become part of the waste stream?
Mhm. Yeah. That's, I don't know, I could see that working in a lot of, places where there's older, I don't know, parts of the country that have maybe fallen on harder times, but are kind of seeing a resurgence, like the Rust Belt. I'm originally from Detroit, so I'm usually thinking about how to help Detroit. But I would think that there'd be a pretty robust market there just with how much that area is changing. But I'm basing that on an assumption. I have absolutely no idea.
No, I think you're right. And I think it's sort of a matter of kind of like what transaction costs are and the value of labor in a market.
Mhm.
So in markets where the cost of labor is high and the cost of delay is high for new projects. So New York City, I think, is a prime example of that. It's really important to be able to make getting those existing materials very easy. And the challenge is kind of getting them in front of designers or people who are going to install them at exactly the right time. But as you move out of these really thick, kind of intense markets and into spaces where things happen a little bit slower and maybe the cost of labor is lower and they are able to take a little bit more time on projects, then that actually opens up a lot of supply. So I think that this is a pretty exciting area in the sense that it has the potential to really be led by areas that are more economically challenged.
Yeah. And I'm thinking storage as well, like you can't store these materials in New York or just because it'd be cost prohibitive. But if you're in, Detroit has a lot of space. I'm sure Syracuse, we were up there, places like Syracuse, Rochester, the upstate, they have more space where they could actually store this so that that's not as big of a concern.
Yeah, and there's like all these amazing stories about reuse centers in various parts of the country, and one of them in DC is one of my favorites, where they have a training program for local community members to learn trades and
Mhm.
then access to low cost materials to install. And I think half of their installations actually are done at low income homes, so they're like fixing up the community. They're running a job training program and they're providing access to low cost building materials.
That is super cool. And you said DC?
It's in the DC area, yeah, and I always forget the name of it.
Okay. I'm gonna have to look that up. That sounds really cool.
It's one of those sort of win-win-win, but I it's also hyper local and it tends to be hard to fund.
Mhm.
So I really applaud the work that Brad Guy is doing, and I think there's so much there also in terms of the non-energy benefits or the non-carbon benefits, which I feel like the best solutions are the ones where we can do them across the board at scale, and where they have other other benefits or other things that they do besides just the carbon savings.
Mhm. Yeah. Cool. I feel like we could continue on this for a while,
Yeah.
but I'm gonna slightly shift. I wanted to stay on policy, but I wanted to bring up specifically Executive Order 22, which is a pretty significant guiding document in New York. And while I was researching you for this interview, I found out that you helped co-author it, and I just would like you to briefly describe it, its scope, and just what kind of the impetus behind it is.
Yeah, so Executive Order 22 is about, I guess it's probably maybe 4 or 5 years old now. It's about leading by example on state projects. And it covers a lot of topics, including embodied carbon, so things like electric vehicles, purchasing of office supplies. For embodied carbon, it has a number of topics that it kind of directs the state of New York to do in regard to its purchasing.
Mhm.
And so the first round of guidance that we issued really kind of like clarified and enumerated what those things are. So the guidance issued identifies the materials of interest, which are the most common building materials, including steel, concrete, and cement, asphalt, and glass. It requires environmental product declarations for materials where those exist.
Mhm.
It also sets emissions limits. It sets GWP limits for some of those materials. And it includes reporting requirements and contract language for the agencies to use. So what that means is in state procurements, so for all of the state agencies that go out and build things,
Mhm.
those agencies are required by this executive order to include language saying that those who win the solicitation need to make an effort to procure low carbon materials and then submit EPDs and information on those projects. And there's a process for doing that. And then there's also reporting requirements for the agencies themselves so that there's information on kind of the amount of those materials being used on state projects. And then again, where the EPDs exist, having those so that we can calculate the emissions.
It's huge. I mean, do you think that this kind of order could be, I don't want to call it plug and play, but the general idea could be used pretty much across any state, or was this very New York specific just because of unique conditions there?
No, I think it's very plug and play, actually. And I think that's one of the things that's pretty exciting to me about this area. So
Mhm.
kind of going back to what's the impetus here? It feels like there's a lot of low-hanging fruit in this space because in the past, everyone thought that the emissions from the building materials were pretty negligible or that they were captured in kind of other areas of reduction.
Mhm.
But I actually work on the industrial team at the Natural Resources Defense Council. And it's kind of amazing how much of industrial emissions have been considered trade exposed and hard to reach. And so therefore, really not much has been done for quite a long time. And the same was the case in New York State when I was working on the scoping plan for the Climate Act.
Mhm.
So this is an area to not only start measuring and benchmarking, but also calling for those reductions on projects. And I think this is actually maybe a good time to differentiate between measurement and design decisions. And this is an area that can get very complicated very quickly in the sense of if you're doing life cycle analyses on a project and identifying hotspots, you end up needing a bajillion different inputs, and it's easy to fall into kind of a false precision mode where you get very hyper focused on the model outputs. And I think measurement just sort of is similar in the sense that it tells you where you're starting, it gives you an indicator of where you're going or what has been achieved, but that's not the thing that's going to reduce emissions. The thing that reduces emissions is decisions at the design stage to use less of a material with a lot of carbon emissions to substitute a high intensity material for a lower intensity one, or to reuse part of the building so that you don't need that material in the first place.
Yeah. And I guess I want to jump to specific materials because that is, again, we had somebody from Proseco come on and they talked about concrete, and it was eye-opening to a lot of people how, I don't know, the challenge is still ahead. But before getting to concrete, I did want to touch on steel. And every once in a while, you'll see talk of green steel, and I don't know how real that is, but I feel like you would be a good person to ask. I'm just curious. So, what's the where does the U.S. steel supply actually stand right now in terms of decarbonization, and what policy levers are being pulled to accelerate decarbonization efforts?
Yeah, I'll share kind of my knowledge on this topic. I'll say that I'm not the expert. I have colleagues that work on this and are able to tell you a lot more. But I think that you're sort of correct in that we do have pretty clean steel production in the US.
Mhm.
And the reason for that is really that there's two types of steel being manufactured here. The first is primary steel, which involves taking iron ore and making it into iron. And
Mhm.
the second is secondary or recycled steel. And we mostly make secondary steel using scrap. So about 70% of the steel in the US is using the recycling method.
Huh. I didn't realize that.
And that's because we're a pretty developed economy and we're a built environment, right? A lot of the stuff that uses steel already exists. And
Mhm.
so like we develop scrap when we're tearing things down, when we're like recycling products.
Mhm.
And we even import a significant portion of our scrap. So we're sort of using what we have here because we have a lot. And other economies are much more reliant on primary steel because they're not built up already. And I think we see that with cement and concrete use as well.
Mhm.
So, which areas of the world are going to be using the most cement and concrete? India and Africa. Why? Because they just don't have as many buildings
Yeah.
as we do. So I think that's super important to keep in mind. And the other thing kind of to note is that the carbon intensive or emission intensive thing is, or most emission intensive thing from steel is the creation of the iron. And so even with scrap, you always need some amount of iron, and that's how you calibrate for the quality of the final product. So in order to create new products from recycled steel, you need to know what the quality of the scrap is, how much iron it needs, how much other processing it needs, and then the quality of the material that you're making.
Mhm.
So one of the areas that we are sort of advocating for is better sorting of scrap so that the higher quality iron can be used to make, or the higher quality steel can be used to make the higher quality products on the output side. And then on the iron side, and this is really kind of the key focus of my team, is about decarbonizing the iron production via a process called direct reduced iron. So this is much cleaner. It's much more energy efficient for turning iron ore into the active form of iron that you would need. and it uses mostly gas, but you can also build it to run on clean hydrogen. And then by using clean hydrogen, that virtually eliminates the carbon footprint, assuming that you have renewable power also. And
Mhm.
so it really dramatically reduces local pollution. And so that's kind of the gold standard and what we would like to see in the US. And the first of its kind full-scale plant of DRI is set to begin operations in Sweden this year.
Well, that's great news.
It is. The tricky thing is that it requires significant capital investments.
Mm.
And as you mentioned earlier, there's, the sort of Rust Belt part of the US, right, has these old dated furnaces, old dated infrastructure in general.
Yeah.
And so replacing that with hydrogen-ready DRI furnaces for both primary and secondary use is a significant investment. And so the company has to be willing to make that, but the steel production margins are quite thin, and it's a global market. And so some type of government funding and support is needed in order to do that. And our goal is really to advance policies that are able to incentivize the companies to do so.
Okay. And I mean, with the existing facilities that are in, let's say Pittsburgh, can they be retrofitted to accommodate this hydrogen powered furnace, or is it just an expensive process, or is it like, no, this facility needs to be torn down, rebuilt, and then the existing infrastructure to transfer the steel still works, but the primary factory is too outdated? Sorry, that was
Yeah,
like a multi-part kind of wandering.
this I think is sort of going beyond my expertise, but my understanding is that we can retrofit existing plants to do this
Okay,
and keep some portion of the existing infrastructure there.
got it. Because that was, again, I always go back to Detroit, but this one of the problems was that it had become so many of the factories were so outdated that they just literally could not even be retrofitted to become a modern factory just because they were from the 1920s or 1930s and couldn't handle. I don't even know what they couldn't handle. I just know that the factories were essentially useless by the time that people were trying to come back and build them back up.
Yeah, the proposal for the DRI furnaces would keep a lot of existing jobs.
Okay, awesome. Good news. And so with the same, we should, I guess, move on to concrete. But one thing I immediately want to ask is that, concrete obviously needs, or I should say, cement needs kilns in order to heat it up to very hot. Can hydrogen work on those, or is that technology not been developed yet?
Yeah, it's a good question. I don't think it's cost effective, but I think that it probably could. This is a little outside of my area of expertise again, but
Okay.
I mean, one of the main ways to reduce emissions. So there's a couple different opportunities for cement plants, and 80 to 90% of the emissions for concrete are from the cement itself. And as I'm sure you and your listeners know, cement is the binder essentially. So concrete is made up of sand, aggregate, cement, the glue, and then admixtures, which are sort of other things that are added for durability and other features. So it's all about sort of like the production of the cement if you want to reduce the emissions. And you can do that through process efficiency at the plant itself by upgrading old equipment, pre-calcining, where you're sort of like using the waste heat. And I always sort of think of that as like turbocharging your cement kiln the way you would on a car with your exhaust heat.
Mhm.
You can also do fuel switching, which is replacing whatever like polluting high emission fuel is being used at the cement plant. Usually it's some combo of fuels, often pretty fossil fuel heavy. So you can use cleaner versions like gas or bio waste instead of like fuel oil, for instance.
Mhm.
And then you can also do things where you're mixing stuff into the clinker so that it's like sort of goes a longer way. So blending it on site. And the best example of that is mixing ground limestone into the clinker, which has been done in Asia for quite a while, but we're a little behind the times in terms of concrete and cement technology development, just since our plants are quite a bit older.
Okay. And yeah, so what are some of I remember speaking with you up in Syracuse about an issue of Portland cement came up. There was a question like somebody was confused about whether they could still get Portland cement or not. And I'm sorry if this is out of line because it's like 2 months ago that this came up, but I know that there's a transition happening with cement in this country, but
Yeah.
how is that going? And I don't know, for folks looking for low embodied carbon versions of cement, like what recommendations would you give them? Like here's the better option of the like 4 or 5 options available.
Yeah, I might back up a little bit and just talk about how cement is made,
Mhm,
because I think that's pretty helpful. So cement is made by mining and grinding limestone. So most cement plants are actually located on limestone deposits.
mhm,
And the limestone is ground and then it is pushed into a horizontal kiln that and then is superheated. And by superheating that ground limestone, it goes through a chemical transformation process that unlocks the carbon atoms that are in the limestone.
mhm,
And by going through that process, there's a bunch of emissions from that carbon being released. And then it creates something called clinker. And clinker is essentially like vulcanized limestone.
mhm,
And then it needs to be ground again. And then when you add water to it, then it has sort of the opposite chemical reaction and then becomes stone again by pulling some carbon from the air also. So there's a little bit of like carbon sequestered in concrete, but it mostly just sort of like goes through this process and then cures and is able to be mixed with other materials
mhm.
to create a very hard product, right? It's been around since the Roman times. And we've known for a long time concrete and cement were like rediscovered about 150 years ago. So the recipe for them was sort of lost to time. And we've sort of known, I guess, for the last 150 years or so that like our concrete is not as good as the Roman concrete. And there have been some like really fun news articles that have come out on this recently. One of them pointed out that like the Romans, I think, were like maybe cold mixing their concrete, and not all of the material was like thoroughly mixed. And one of the things that they added to their concrete mixes is fly ash from the, volcanic like eruptions and like
Vesuvius.
deposits that existed. Yes, all over. And so they would mix volcanic ash in, and that increased durability. It made it less brittle,
Mhm,
and made it last much longer. And so the sort of new discovery is that like these pockets of unmixed concrete, including cement, then as let's say like a bridge would shift over time and develop a crack, water would then get into that crack and it would allow for this chemical reaction process to occur and like essentially create some new concrete to fill the hole.
huh.
I love that example because it's, fascinating, but also I think it's like a good example of sort of like how the chemical process works. And so concrete batch plants, ready mix concrete batch plants, essentially are logistics operations. And so they have about an hour and a half to 2 hours total from when all of the materials are dropped in from the hoppers into the truck and then they start rotating to
Mhm,
when they get to the job site and pour the concrete. And so getting back to your original question about, what can we do in terms of being able to reduce emissions? So the clinker, we're sort of discovering that like you can mix other things into clinker and actually have better cement overall. And so we're pretty focused on lowering the percentage of clinker in mixes.
mhm,
And one of the most effective things that you can do is ask for a concrete blend that includes cement, which has a lower clinker factor and has other things like supplementary cementitious materials in it. So supplementary cementitious materials, or SCMs, is just kind of a fancy way of saying like other sticky stuff. And some of them are like sticky on their own, and others, like ground glass pozzolans, are sticky when combined with clinker. So ordinary Portland cement, or OPC, essentially is just this like very basic mixture, the thing that's been around for the last 150 years. And so you can still get that, but like concrete mixes essentially are like cake recipes. And so depending on the type of thing that you're building, you'll want a different cake recipe.
mhm,
And the way that's determined is like the ratios of these different materials and also the admixtures or the SCMs that are used.
mhm.
And If you use more SCMs, then you'll be able to have a lower clinker factor and also lower emission concrete overall on a project. So, in terms of actions your listeners can take, they can ask for low carbon mixes, and the specifics of the low carbon mix in their region will probably vary depending on the availability of these supplementary cementitious materials. So, in the New York area, for instance, there's a company called Urban Mining that's making a material called Positive, which is made from ground glass from the recycling centers in New York City.
That's really cool.
So that glass, when mixed with clinker, then also becomes cementitious, but not cementitious on its own. And I think they're now approved for New York DOT, and they've been doing a number of demonstration projects. But that material is not available, let's say, in Oregon or Washington, right?
Yeah.
They're going to have a different supplier. So that's kind of why I say that it's pretty local, but it's also a thing where a lot of the national ready mix plants are like stocking blended cements as part of their standard mixes. And so that's a thing that customers can ask for is low carbon blends or low carbon concrete blends. And then in addition to that, they can ask for these SCMs that could be added in addition to the blends of the cement itself. So two potential points to reduce clinker factor at the cement level and then again at the concrete level.
That's really cool. And like how, I mean, I'm sure it changes the kind of, drying time or, certain elements of the final product. Have there been good studies so you know what you're getting and you have all the data kind of ready to go so you're not leaving anything open to chance where you're like it should hold. We're pretty sure, or is it like all of this data is readily available?
There's lots of different mixes. And so some of this has a lot of information. Some of them have a lot of information available on them, kind of going back years. So the two most common SEMs are fly ash and slag from steel production. And fly ash is typically from coal production. Both of those are going away because we're not producing as much steel and we're phasing out coal power plants. But there are, like on the West Coast, for instance, like a ton of like volcanic rock deposits, right? So like California, Nevada, Oregon, lots of materials that can be mined easily. And some of those there's like good information on and they're being tested by DOTs and others. I think that the tricky part about this right now is that like it seems that each agency wants to do its own testing. And some of these, there's like actually like really great information that a different DOT has tested. Minroads in Minnesota has like a wonderful data set, and they have actually a test road where they're using these different materials. And so they're a great source. The FHWA, Federal Highway Administration, also has been a great source for information on this in the past. I think that one of the things to keep in mind kind of about these different materials is that you can use there's probably a lot of data out there. You can use the data that is provided by, let's say, like your GC or your concrete supplier, or you can actually do a test pour. And this is what a number of the hyperscalers are doing for structures that they're building, where they actually are kind of like driving the market in many ways for these low carbon concrete mixes because they're building and it's part of their like companies' sustainability goals, let's say, to use low carbon materials. And so on their projects, they want to make sure that it's not going to delay the construction. And so kind of a good rule of thumb is that like the more expensive the project, the more adverse they will be to delay, and the more any kind of delay is like pretty untenable. So for those projects, they're doing a number of test pours with the concrete mixes that they plan to use to make sure that they're going to meet their hardness and other quality attributes at 14, 28 days.
Nice. So I'd like to shift to mass timber, if that's okay. And I think that there's a lot of interest in it in our community and a lot of, let's say, positivity around it without always, I feel like sometimes there could be bad actors that want to exploit that good faith in mass timber. I guess my question to you is like, how can a team that wants to use mass timber, like what red flags should they look for how can they avoid basically like greenwashing, where it's just like a logging industry that doesn't give two craps about the environment, like throwing together some product. Like what kinds of products should these teams seek out, and what kind of products should they avoid?
Yeah, this is a really tricky one.
Yeah.
I think that sustainable sourcing is like a really like good place to start.
Mhm.
And looking at the distance that the wood has to travel is really important. So how the forest is managed matters a lot. The age of the wood also matters. We know that that trees absorb carbon at different rates depending on like their age. Basically, there's like sort of a curve over time, which is specific to the different species and regions where they live for kind of like what their carbon absorption rate looks like.
Mhm.
And the impact of the forest, like how the forest is managed and like kind of other things that that impacts in the ecosystem matter too from a carbon standpoint as well as an environmental standpoint. And the processing that it has to go through and how far it has to travel. Travel is like very significant, particularly truck travel, because there's a lot of tailpipe emissions associated with it. So
Sure.
locally sustainably sourced woods are a good place to start. It is very case specific, and I think that you have to run the numbers and just kind of know that like it's not always going to be a low carbon alternative. You have to kind of like plug it in or rely on professionals in your region who've already kind of done that.
Okay. That that makes sense. And I mean, have you seen more mass timber, like just essentially, are you seeing more companies kind of start to use mass timber and more builders use it on a larger scale, or is it still a pretty niche thing for smaller projects?
Think we are seeing more of it overall. I mean, it lets you do things architecturally that you can't do with standard lumber, right? And I think that the mass in the mass timber lets you have much longer, larger spans. So
Mhm.
you can have lots of open spaces and it lets you carry load differently in buildings. So
Mhm.
I think that there are other reasons why people are choosing mass timber besides just the carbon elements. It's also, you know, a lot of these timber products are really beautiful
Yeah.
and they're selected by architects for interior applications and for their kind of aesthetic value also.
Mhm. Yeah, and this might be kind of left field, but I forget where I even went. I was in San Diego and saw the world's second largest outdoor earthquake simulator was testing a 9-foot tower made of mass timber. Does it seem like it has really good seismic resiliency compared to some of these other materials, or is it more or less the same, or is that something you're not totally familiar with? Because that is kind of left field.
Well, I'm from California, so I learned in grad school in my architecture class that there is nothing safer in an earthquake than a single story wood frame house because it wood flexes, right? And
Yeah.
so in earthquake zones, it's not just about the ability to kind of withstand the shaking, but it's also accounting for shear and kind of what state the building will be in after.
Mhm.
So yes, wood is good, especially for you know low rise residential. It's very beneficial from a seismic standpoint.
Okay.
It also has to be tied to the foundation, and you want to make sure that those elements are reinforced and that you have it braced for shear. So it's there's sort of more to the story also from a seismic standpoint.
Okay. Sorry, I just it dawned on me. I hadn't thought about being there in a while. I was like, I wonder if that study bore fruit, and now we're seeing more, wood in seismic zones because it's, I don't know if pliability is the right word, but just a bit more, it wiggles without breaking.
Yeah, yeah, I think that's really correct. And I feel like kind of like one of the themes of this interview is local construction and local knowledge and local needs. And over the last, I don't know, like 75 years, construction has gone from like vernacular architecture that's very place-based specific to kind of universal architecture where we're building these boxes with mechanical systems and lots of curtain walls and you know glazing and they're designs that can kind of be plopped down anywhere
Mhm.
and built without a lot of attention to like local weather conditions and local materials. And one of the best ways to reduce emissions, and I think just build better overall, is to pay attention to those things and think about what's available locally, what materials, what SCMs can be part of your concrete mixes, what masonry might be available, what timber might be available, and how thick your walls need to be. I know that earlier this month there was a Passive House episode on hay bale houses and hay bale wraps, right? That's a thing that like people have been doing in the Southwest for a long time in terms of like thick walls, adobe bricks, using clay, using straw, right? Those things, straw as a material also that sequesters carbon. Any biostrates, any bio-based materials that are used durability wise beyond their sort of natural life cycle
Mhm.
can sequester carbon. I think that's like a good rule of thumb also. If you're kind of trying to decide, is this thing going to be carbon beneficial? You're like, well, what is its natural life cycle? And will the building or the thing that I'm putting it in be in existence significantly beyond what it would be naturally?
Mhm. That is a good, yeah, I like that. And that leads right into kind of the next question I wanted to ask, which was about bio-based materials, which you already brought up straw, but there's some other materials that are coming online that like hempcrete gets a lot of buzz, and I remember hearing about eelgrass mostly because it's really good for like sound abatement.
Hmm.
But I'm just wondering, like, where do you see these kind of fitting in the larger decarbonization toolkit, and if there's any like policy support, or I guess even like financial support coming from the states or the federal government to kind of lift up these industries and get them moving, because I'm sure they need a boost would be nice. But I don't know. Do you see them moving beyond niche applications anytime soon, or are they kind of going to be there for a while?
I think that we like don't have great information on their potential to scale right now. And my former employer, NYSERDA, has given out several rounds of grants for natural carbon solutions that
Hmm.
are looking at this at the building level. And I think they've done two phases, two rounds so far, and are kind of like, testing these different materials that are available. And I know hempitecture is one of them, and there's another one I think that's looking at grasses and kind of, I think there might be a seaweed one also. So they're essentially like trying to gather this and kind of think about what it would take to bring it to market.
Mhm.
We know overall that yes, like bio-based materials, great way to store carbon.
Yeah.
It's the sort of like business development side of it, of getting it into a product and pricing that product affordability and then getting it out to builders that is really tough. I was also just reading about a building board made out of sawdust. And I know that there's one that folks like to use in the Southwest, which is I think sawdust and lime and cement.
Huh.
And so there's a plethora of these types of products, but they have to be like priced competitively and they have to be available where the builder is.
Yeah.
And I think that that's really the challenge right now.
Okay. Because that's, yeah, I'm specifically with hemp. Just in another life, I did a lot of research into the cannabis industry, and like the amount of hemp you have to produce to get enough distillate to make it like a THC product that people want to take to, for recreational or whatever purposes. Like you have to create a lot of just biomass.
Yeah.
And I always wondered kind of where that went.
I think you're right about that though. Hemp is a hard one also because it's from a plant with a controlled substance.
Yeah.
And so I was talking to a builder recently who said that he was building houses in Vermont
Mhm.
with hemp insulation and that he had to get his hemp from Canada because it's just like too complicated to grow it and source it in the US.
Yeah.
And obviously Vermont very close to Canada, so not too heavy a lift for them, but hemp is a tricky one, even though it has like very high carbon sequestration potential. My advice to folks wanting to use bio-based materials is see what's available in your local area. Look at waste streams.
Mhm.
As you identify like agricultural waste, see kind of, like corn husks, coca husks, that type of thing. Those are like packed cellulose, like these types of things from agricultural processing are really great places to start. And often there are people who have developed a product around it.
Yeah, we've seen quite a bit of straw, like basically pre-manufactured panels that use straw, cut straw as their insulation. And when the amount of straw that gets produced in this country in Canada is just enormous. So I mean, it's a readily available resource for a lot of communities, particularly in the kind of breadbasket of the country.
Yeah. And I would say don't get too hung up on what the bio-based material is. I
Mhm.
think it's more important that it's local and available.
Excellent advice. Cool. Well, I guess I want to ask another, if you want to give some other advice for folks who are in the private sector looking to minimize embodied carbon, but have absolutely no idea where to start. What steps can they take to ensure that the products they end up using actually align with what they want to do in the project's intentions?
Yeah, thanks for asking this. I think, because this is a new area for many, I
Mhm.
think asking is a really great first step. So asking if there's a low carbon alternative, asking if there's documentation, EPDs or health product declarations, HPDs are good places to start.
Mhm.
Also, documentation in general, we've found that typically products with more documentation are going to have more care, kind of as a general rule, around their production.
Mhm.
Not always true across the board, but often those tend to be higher quality, and there's more attention to kind of what they're produced with and how.
Mhm.
And then also talking to colleagues, peers in the space. I feel like I just keep hammering on this, but for Passive House, right, I remember the early days where nobody knew how to get any of these Passive House materials or how to build Passive House. And the whole point of the accelerator, right, in these in-person meetings, the Passive House Accelerator group was to get together and learn and trade information. And I think that that's so important here in this space as well.
Excellent. Yeah, I couldn't agree more. I feel like that has been just watching how this community kind of interacts. People don't like to even design details and stuff. Like nobody wants to keep anything as proprietary. They want to share it, and so yeah, I think that's excellent advice. Cool. Well, I do want to wrap up here with one final question, and this is about your work with the New York State Embodied Carbon Working Group, which will soon be releasing a comprehensive action plan. What are the highest impact recommendations you can make to policymakers in other jurisdictions? And what does implementing an embodied carbon framework look like at the state level, especially when balancing emissions reductions with workforce development, economic competitiveness, and realpolitik of the construction industry?
Yeah, thanks for asking this. I really appreciate it because I think that like when we have these kind of sort of macro micro type discussions,
Mhm.
you can get a little bit lost where you're like, okay, what do we do?
Yes.
And I think what's really exciting to me about this space is there's just so much low-hanging fruit and there's so much that can be done. So for states and policymakers where nothing exists, the first thing that you can do is you can start data collection, you can add low carbon specifications to state procurements. What does this look like? This says if you're going to procure concrete, procure 20% less than the industry average, or procure concrete that has environmental product declarations, and then maybe start with that and then adopt GWP limits and requirements to procure less over time. This is a thing that policymakers can do that will not increase the cost of those procurements. You can keep the cost the same and have this be a threshold requirement that all of the bidders have to include if they want to be considered. I say this as somebody who has done state procurements before. It's very hard to get out of least cost procurement requirements, as many states have prescriptive rules that have to be followed. And so the way that you do it is that you say, okay, we can't award, maybe we can't award bonus points for this. If you can, that's great. You should definitely award bonus points. But if you can't, you put it in the list of requirements that have to be met by each bid in order to be considered and scored.
Mhm.
And then the next thing that you can do is you can have incentives available for a use of low carbon materials. So in New Mexico, earlier this year, NRDC passed a bill that set up an incentive program providing incentives for low cost building materials. That is very easy to do. There's a lot of existing energy efficiency programs where you can just add additional money for embodied carbon reductions as well. And I'll just kind of note that what I think is best practice, what I'd like to see eventually is that we do life cycle analyses for projects and understand the trade-offs between operational emissions reductions and embodied carbon or material-based emissions reductions so that we can go in and most cost effectively use incentive amounts to reduce emissions. So we understand what those trade-offs look like.
Mhm.
And then I'll also note that we're supporting 3 bills by AIA New York this session in the New York legislature. One is a codes bill that would include a 3 code pathway approach similar to California's CalGreen for
Mhm.
embodied carbon. And that's a really great example that can be replicated elsewhere. We're also proposing financial tools for embodied carbon that includes a sales tax exemption for low carbon products and materials. That's another one that I think is very easy for states to adopt. Colorado has done this already. And then also adding embodied carbon to the eligibility criteria for commercial PACE or property assessed clean energy financing. And that's at no cost to the state also. That just kind of allows low carbon materials to be included in the list of existing measures that can be financed.
Wow, that's all great advice. And I feel like especially the sales tax one is real easy to do and should be a pretty light lift for most folks.
Yeah, we think so.
All right. Well, Mikhail, thank you so much for taking the time and going a little bit over, and by a little bit I mean a lot over what we were supposed to keep this to. Yeah, this was a really great conversation.
A pleasure. Yeah, love talking about this stuff, and it's such an exciting area, and it's really fun to get to work on it and to tell other people about it. I think it's a thing that intuitive makes a lot of sense for those of us that dislike waste and have been thinking a lot about how to construct better buildings.
And that was Mikhail Haramati. Fantastic interview. Really enjoyed that. Thank you, Jay. I might kick off with some of my highlights because I really liked that. There's a few things that she said, but one was the huge impacts that materials have
Mhm.
versus incremental energy efficiency improvements. And that kind of made me pause and think about, we spent a lot of time tweaking windows and improving systems, mechanical systems, which is all important for the
Yeah.
ongoing operational energy reduction of a building. But as Mikhail pointed out, some of the massive impacts are literally fixed right at the beginning of a project when you're deciding not just how big it is, but what are the mass materials that building is going to be made out of, and that's a huge amount of energy and carbon there right up front, which I think is a really important perspective to keep in mind.
Yeah, and I think it's something I've brought up a couple of different times with interviews that get into embodied carbon is that when I started doing this and not coming from a building science, but just as a writer, I kind of got dropped in and this was a conversation not a lot of folks were having even 5 years ago. And it's just been amazing to
Mm.
watch how quickly it's kind of become a more important topic. And, obviously her policy work has been a big part of that, but just throughout the community, the high performance building community, it's become a lot more important to folks as they're building these projects.
Absolutely. Yeah, I definitely thought that when I was listening, thinking, I mean, from my point of view, America doesn't have a reputation of being a leader in global energy efficiency or anything to do with climate. Just putting it out there. So it's really encouraging to hear people talking about things like this in a way that makes it seem like this is the way forward and this is now how we're choosing to do things, even if it's that practice or that city or state.
Mm.
Just the way that she was talking about, well, this is how we design now. And it's kind of making upfront carbon and embodied carbon not just standard practice, but kind of cool and expected. That's a real mind shift, like you say, from just a few years when it was all about just the cheapest material and what's available. but flipping that around to say, this is actually really important, and we have the tools now and the expertise and the options in order to do something about it. And that's quite a big mind shift, I think.
Yeah, absolutely. And I think one of the big things that I was took away from it was how much power states and I guess even cities have when she said that
Yeah.
50% of concrete is used by, states or for kind of these municipal projects. I'm sure for probably roads and bridges rather than buildings, but
Yeah.
still a tremendously huge lever that if you can pull on that and kind of influence the rest of the industry to change, that could be
Yep.
huge. So yeah, that was
Yeah.
one of my big takeaways.
Yeah. And I like that idea that a state level is still really, it's big enough to matter,
Yeah.
as Mikhail put it, but it's not too big to change. And so I think that's a really good, impactful level of change that you can have, because it does make a big difference. And we see that in places like Massachusetts, which is having a huge change of policy. And then others will look at that and regardless of what's happening at the federal level, that you sort of make the change inevitable from the states. Related to that, right at the end, I guess the main takeaway from me was how positive and excited Mikhail was about the whole thing. And that is really cool as well, because I think it's really easy to get overwhelmed and a little bit depressed about everything.
Yes.
But to have someone who's genuinely excited about this work and is really positive about what they're doing and bringing other people along on that journey, that's critical.
Yeah. And I think what I really liked hearing, I forget exactly where she said this, but it was either towards the end or in the middle, but about, a relatively small number of practitioners can kind of make a huge impact if you're doing something really pretty radical that nobody else had considered. And you see this obviously with the Passive House community with embodied carbon, but this was about Brad Guy and his work for disassembly and how you have a pretty small group of people kind of realizing you should be reusing a lot of these building materials and kind of creating
Mm.
markets within like Portland. I'm sure there's somewhere in Colorado and somewhere in the Northeast. These are going to start really small, but they're going to expand. And suddenly, we hope, fingers crossed, the next 5 years, it starts to become kind of a normal process. Maybe not the
Yeah.
mainstream, but at least not totally niche.
As it has happened, and as Mikhail said, this was something that no one was really doing a few years ago, and now it is becoming more standard practice. So, and we often forget where we've come from. So I think it's good to recognise that. Very good, and good to hear a few shout outs back to NYSERDA as well. Obviously, Mikhail has done work there, and always been a great supporter of Passive House Accelerator, and that, I think that it's really great and important to recognise that that's bearing fruit now after the years of work that they've been pushing a lot of this stuff. So I think it's quite nice to recognise that too.
She mentioned a firm in DC that does, reusing materials, job training, and kind of fixing up buildings within that community. And I did some research. I'm pretty sure she was referring to Community Forklift. So if folks want to look into them, it seems like a very cool organization.
Nice.
That's a very unique organization, but it'd be cool to see more folks following that model.
Yeah, absolutely. Very good. All right. So, hey, well, thank you very much for that, Jay. Nice to hear your voice on the podcast again, and always bringing us fantastic interviews and great content. So, really appreciate that. Now, Passive House Lives are taking a break at the moment for the US summer. So, yep, there's lots of content that you can go back and rewatch or catch up on. And of course, we will be back again and continuing with the Passive House podcast as we go through. So thank you very much, Jay. And to everyone else, tune in again next week for the Passive House podcast.